Hey, that is my first video on YouTube, and this video is going to be dedicated to the algorithm, and this whole channel is going to be actually dedicated to the to actual implementation of various algorithms or various data structures, mathematical algorithms. This channel is actually going to dedicate to this kind of stuff. But today, what we're actually going to do, we're going to review the algorithm which is called the middle square method, middle square algorithm, yes. And it is pretty simple. This algorithm serves as the method for generating the random sequences of numbers, just sequences of random numbers, I'm sorry. So, and what's the actual method? We have a number, initial number. We gotta square it, and we extract in the middle out of the square number, and we get another number. And after that, we repeat the process, and you just know we're doing this all the time. So this algorithm has the disadvantages, which I'm gonna point out in the end of this video. But right now, we're only gonna actually dive into the implementation of this algorithm in the C++. Yeah, so let's start. We have our lambdas, which are going to be our helper lambdas. The first lambda is going to return the number of digits in the number. And the second is we just got to actually extract the middle out of this number. So first we got to actually check if the number of digits in our initial number is even, because actually the algorithm, which is, we have this in here, so the value of n must be even in order for the method to work. Actually, yeah, we gotta have the starting value, number of digits, and starting value gonna be it gets to be even. I'm really nervous right now because of like the first video. I really apologize for that. So we check in this. If it doesn't satisfy this property, then we are see out this message and return from the method from function. So otherwise, we are we getting the number of digits from this number. Then we assigning this a process number, and I'm using those precious auto. Yeah, I love them. So then we create a steady scarcity. Just like it's really intuitive thing. You're not gonna actually know about it much. So in here, so here is pretty starts some really interesting thing. Here starts really interesting, really fascinating thing. So we find a square of the number of this number of starting initial number. Yeah, so we find a square by using the POW method from std. So then we gotta turn it into the string so that we can extract the number of digits from this number, and we're using this lambda helper defined earlier, number of digits. So that way we actually get the number of digits in the number. Then we're checking if the number of digits in the square is less than 2 times the number of digits in our starting value. So because it is in order to actually extract the middle out of this number, we gotta have the number of digits in this number twice as big as this starting value, as number of digits in the starting value. So that's exactly how we define this thing. Then what we actually gotta do is if it less than 2 times number of digits, then we turn it into the string. While this less than 2 times number of digits, we actually gotta insert the zeros in the beginning. So and we have this in here also. So I gotta show you this. I'm sorry, just where it was. To generate the sequence of n-digit pseudo-random numbers and an n-digit starting value is created and squared, producing a 2n-digit number. Yeah. If the result has fewer than 2n digits, leading zeros are added to compensate. Yes, that's exactly what is it. So that way, actually squaring the number of digits, we are advancing the number of digits in square number and extract the middle. Else, we only just need to extract the middle, and we are done. Then we actually see out the result and assigning the new results to the process number, and we're doing this again. And we're doing this number of iteration times, which is passed in here. So, and if you want to see the result of this, then I'm going to run this, and yeah, you see this beautiful sequence of random numbers. Yeah, that it is. So the algorithm actually has some disadvantages. So it just cannot work with the numbers whose number of digits is not even. So we just actually denote it here. The value of n must be even in order for the method to work. So we have this problem when we have a number, for example, 540, which is squared, and it produces the 291 and 600. If we somehow got to extract the 3-digit number, but we can't do this. We can only extract the 2-digit number out of from the middle, but we just can't extract the 540 from the middle because we just can't do this. So that's actually it. This is my first video, and I'm really nervous about it. And it's going to post it on YouTube. Oh man! So maybe I'll post another video a little bit later. I don't know what algorithm I'm going to be implementing, but hopefully I will come out with that. So thank you for watching, and hit the subscribe button, and hit the like button. So thank you very much for attention. Goodbye.